Hello, guys, and welcome to another one-on-one lessons. This is science. Oh no, this is math. And now we are working on representing linear relations. So basically, just graphing like real life scenarios and cases into like graph linear relation. All right, Mr. An, right?
Yes.
All right.
So
So let's continue.
this is a graph of a hot air balloon descent from 300 meters to 0 meter
Mm-hmm.
at from 5 minutes. When does the balloon reach the ground? 5 minutes. So you can see because when start at 300 and then you mu- for every minute
Every minute's
you
like minus
decrease,
60.
you minus 60 meter
Uh-huh.
and and then when you reach to the ground, so it becomes zero. So that's when you reach the ground.
But you have to understand that basically this
Yeah,
is like a perfect situation. They didn't talk about like air resistant or any kind of factors that can affect the speed, right?
yeah.
So
So
this is like a perfect situation when it's like going very smoothly down, like a oh, your brother is really loud.
wait, I'll tell him to be quiet a bit.
Shh. Or maybe you can just move away from it. Are you using computer or laptop? Okay, fine.
Back.
Uh-huh. All right. Are you using computer or laptop?
Uh,
PC.
Laptop.
Oh, okay. Just you can just move away from him a bit.
Yeah.
Just move away from him. It's much better.
Currently moving away.
Uh-huh.
Now it's more isolated.
Mm-hmm.
So here are the suggested answer. Using the graph, find the point at which the height is 0 meter. That point is 50. The balloon reached the ground at t equal 5 minutes. Using the equation, set the height to 0 meter and solve for t. Height equal minus 60 plus 300. So the height is 0. Then you minus 300. So you remove the 300 each. And then you divide 300 by 60 and you get 5 equal time minute. So the balloon reached the ground after 5 minutes.
Mm-hmm.
And for use the equation to determine the balloon height after 90 seconds. The answer is
Okay.
210 meter.
So 90 second. You have to convert 90 second to minutes now because time now is calculated in minutes, not second, right?
Yeah.
So now 90 second becomes like 60 plus 30. So it's 1.5 minutes, 1.5.
First, the time must be converted into minutes. 90 second divided by 60 second slap per minute equal 1/5 of a minute. How substitute 1.5 for t in the equation and solve for h, which is height. So the t is 1, t stands for time, so it's 1.5 minute. So 60, you multiply 60, you multiply 1.5 and it's equal to 90. So 90 plus minus 90 plus 300 is equal to 210 meters. So the balloon will be 210 meter above the ground after 90 seconds, which is also 1.5 minute. Try it. 2 more scenarios follow. Do at least one of them completely and be sure you can do a similar one on your own.
Okay, let's say bamboo is an important crop in Vietnam.
It's
Why it always have to be China? Of course, Vietnam grows a lot of bamboo too. Wood to food to paper to plywood.
It grows at an astonishing rate. The following data for height versus time were collected and are displayed on a graph. So this is the graph here. How tall will the plant be after 10 days? So after 10 days, it will be about 8 feet tall. 8 feet tall. That's kind of weird. The bamboo growth will be at 8.
1 feet is
8 feet tall.
1 feet is like about this much. Because basically that's the length of your feet, or basically your shoe.
Yeah.
So 8 feet is like 2 meter 40, because a feet is like 30 centimeter. So 8 feet is like 240 centimeter. I mean, a tree can be that high. Why not? I mean, it can even be higher than that.
That's cool. Determine the initial value and rate of change for the relation. So the suggested answer is the initial value is where the line crosses the vertical axis, which is at 0.5 feet. The rate of change is found by constructing a rate triangle between 2 points on the line of best fit. The point 6,5 and 1411 have been chosen. And the rate of change is 0.75 feet a day. So the initial value start at somewhere here, and then it's moving 0.75 a day, and
so for 8 days, it changes from 6 to 14 feet now. Wait a moment. This one, it's like...
No, this is like different.
5 to 11 is like feet. So 6 feet in 8 days.
6 feet in 8 days. Determine an equation for this relation.
Can you do that? Okay, we did that before.
Yeah.
X equal to ax plus b something. And you put in there, and then you can solve it. Okay, let's choose the value of 0 first to make things easier.
Value
Initial
of
value is like
0,
0.5, 0, 0.5.
0.5,
Equal to 0x plus b, 0a plus b. Yeah.
so I think it would be height equal, wait, what?
Wait, what did you do?
It's close. I didn't do anything, it's just automatically closed.
Weird. I don't know why. Must be a huge glitch for your laptop. 45
Yeah, we,
9. No.
anyway,
0.
so so the height would be this equation would be height equal 0.75d
Plus 0. Plus 0.5, right?
yeah plus 0.5.
Right. So height equal to 0.75d plus 0.5. Yeah, it's better if you space it.
Oh, sorry. And it's just this answer is the equation
Correct.
of a linear relation can be written in the form dependent variable equal rate x independent variable plus initial
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 value.
value. Yeah. For this scenario, height equals 0.75 a day plus 0.5, where height h is the height in feet and d
Moment.
is the time in days.
Alright. How tall would a bamboo plant be after 365 days? You just have to plug into the equation now.
So 0.75 times 365 is
365 and then plus
about
0.5.
273.75. 273.75 plus 0.5.
Wow, that's really high.
But logically, a bamboo cannot grow that tall.
You think so?
I think.
Is it like 274 something centimeter, right?
No, it's like feet, so it should
Oh,
be
feet.
taller.
Sorry. I mean, that's too high. It's not a reasonable prediction because you don't have any bamboo that is that high, of course.
Yeah, but
So this is only like theoretical prediction, but no way it's gonna be that high. It will stop growing at some point and slow down, something like that.
this is not logic. It's like not logically possible. So Since the time value on the graph extended only to 23 days, use the equation to make this prediction. Substitute 365 for d. H equals 0.75d plus 0.5 equals 0.75 multiplied 365 and plus 0.5, which is equal to 274.25 feet. This is likely not a valid prediction. At some point, the growth rate will slow down and the plant will reach a maximum height. In reality, the maximum height of a bamboo plant is reported to be approximately 90 feet.
Mm-hmm.
So it's like not possible to grow that long. What is the verbal description of this relation? Height of a bamboo grows 75 feet a day.
Verbal description.
Uh,
0.75 feet a day. It's like 20. Oh wait, 20. No, 30 centimeters. So basically, 0.75 feet a day. It's about 22 something centimeter a day. That's really fast, you know. You wouldn't
yeah,
expect
it's really
bamboo to be that like that, you know. It's too fast.
in reality, does a bamboo grow that fast?
No, it's not gonna be that. It cannot be that fast, you know. Unless it's like mutated bamboo, something like that.
Like you experiment with it?
I know, yeah, because basically a bamboo tree it requires 2 or 3 years more to grow to that length, that height of like human height, I think, or even more. So it cannot grow that fast. Impossible. Okay, so this is just like theory.
Yeah, theory only.
Okay, let me take a break first. All right, let's continue now. Scenario 3: speed versus time.
Maria is driving at 50 kilometer per hour. When she merged onto a highway, she increased her speed at a rate of 5 kilometer per hour every second. So create a table value to show Maria's speed versus time data. This data where the independent variable begin at 0 second and increase in increment of 2 second up to 10 second. So time, so every 2 second is another 10 kilometers. So it's 60, then 70, and 80, 90, and 100. And the scatter plot is you can see Marie, she's moving every 2 seconds she's moving up to move up to 10 kilogram 10 kilometer for every 2 seconds. And the equation is equation is um, speed equal by t plus 50. Speed equal by t plus 50. And the suggested answer is, from the verbal description, the initial value is 50 kilometer per hour and the rate of change is 5 kilometer per hour per second. The equation of a linear relation can be written in the form dependent variable equal rate x independent variable plus initial value. For this scenario, s equal 5t plus 50, where s is the speed in kilometer per hour, and t is the time in second. The rate of change could also be calculated using any 2 points from the data table or graph. If the point 470 and 1000 are selected, rate is equal to change in dependent variable divided by change in independent variable. So 100 minus 70, 10 minus 4 is 30 divided by 6, so the rate is 5. The rate of change is 5 kilometer per hour per second. When will the speed of Maria car be 63 kilometer per hour?
Just try to solve it first, huh?
Yeah, sorry. It's kind of hard.
Just put it in there. Wait, this is speed, right? Okay. So you
Yes,
just they asked you when would the speed of Marina's car be that much 63 kilometer per hour? You just have to plug it in. 63 point something equal to 5t plus 50. And you can find for t. Remember, t is in second.
Okay, so equal 5t plus 50.
And then you
So
plug the speed they want you to do now. So
I
is
need
equal to
5 and then it's
no, wrong. So they give you the speed. So you have to plug in the S, not the T.
Oh, sorry.
Okay.
3
Okay.
equal 5 times plus 50.
And then you solve for T.
So t is, well, we don't really know what it is yet. So
So that's why you have to find T, because they ask when, you know.
bring the 50 to the 63. So and then take 50 and minus 63. So it's some space. 5t. So 50 minus 63 is equal negative 15. Negative 15, and then you divide by 5, and then it's t, so 13, negative 13 divided by 5 is negative 2.6 equal t. Oops, I did it wrong. So this should be changed. 63 minus.
That's why you do it stepwise, okay? Don't skip steps.
Sorry.
Okay, so basically you have negative 13 divided by 5 is 2.6 seconds. That's the speed. That's when the speed of Marina's car will be 63 kilometers per hour. But my question is, why t is in second now? While the speed is in kilometer per hour, doesn't make sense, right? Let's look at the question. Can you scroll up? Okay, they
Yeah.
give you the speed in kilometer per hour, but now the time's in second, not hour, which is really weird. It's not consistent, you know. Even though you can still get to the right answer, but still, I don't like the units here. I mean, it's just not consistent. It should be like hour and then kilometer per hour, you know? Should be consistent.
Yeah, I think it's kind of weird. But anyway, let's just move on. What are the limitations for this model of the speed of car, for the speed of Maria's car?
I'm still coughing from yesterday's video.
Oh,
It's like I talk a lot on my writing videos.
oh, are you okay?
No, I'm fine, I think. It's not COVID, don't worry.
Oh gosh.
Not Omicron. Omicron.
What? Okay. What are the limitations of this model for the speed of Maria cars? So, um,
Now, what's the
so I
limitation?
think, so I think she had to slow down because
It's not realistic
usually,
because there are a lot of factors that involved in this one, in her speed. Basically, in reality, people never just go up or go down. They take turn, go up and down, up and down, up and down, right?
yeah, because there's like speeding limits.
Of
So,
course.
so she could, like most highway are like, in this scenario, like most highway are like about like 100 kilometer per hour. No,
Yeah, highways like 100, I think. I think maximum 140,
yeah.
but I think 100 is the best bet. Oh, I'm again. Oh, the share screen
Oh
stopped
no,
again. No!
just I don't know why, but it's keep doing that. Maybe it's Zoom.
Zoom is laggy because a lot of people is using it.
I got background. Share.
Some highway usually have a speed limit, and you cannot exceed that. Okay, so you're working on it. What equation to represent this relation? Number of tiles. Wait, the only 2 points? 3 points now. Okay, you do it. Y equal to ax plus b. Okay, number of tiles equal to figure number times something plus something.
Just share. So figure number times 2 plus 3. Yeah, I think this is it. Yeah, since number of tile equal figures. Number times 2 plus 3. Yeah. Examine this table of value times minute. So graph like this. An equation to model this relation. So 15 so the equation would be 15. No, it would be distance equal equation to model this relation. Take
Okay. There's a graph distance versus time.
um, still thinking. the equation.
Right equation. Same task. See if you can do it.
I think the equation would be distance equal u divided by 5t plus 15.
Mm-hmm.
Yeah. So it would be distance equals 0.6 times
T
plus
plus
15.
15, yeah.
Ah, look back at the table of value. Is this linear relation? How do you use the table of value to answer this question? Um, is a linear relation. And
It automatically turned off the share screen again.
yeah, I think people are using Zoom very often, so
Too many. It's lagging. It's basically so laggy. My god, Zoom server need to fix themselves so much. They need to basically fix all the bugs and things. Otherwise, people are gonna use something else like Google Meets or other competitors' products. Just look at the table, you can see if it's a line, it's linear. No need to do any calculation. Just look at the line, you see it's linear. Good. Time is independent and shown in minutes. Distance is dependent and shown in kilometers. Wait, you got it the opposite way. Because why time is independent? Because you can just choose whatever time and it will show the distance, isn't it? So it means that you have to choose time and the distance will follow, isn't it? So the distance is dependent on the time and the time is independent. You are still confused with this part, do you? Okay, then you have the equation. You can just estimate the distance. She will run in 22 minutes. You don't have to even write equation. You just look at the graph and then you can put a line and then, see. So in 20 minutes, probably about... No, that's 15. No, that's 15. We're asking for 22 minutes. So, not there. A bit to the left. There you go. That's 22. And you go up. And then you go up there. It would be about 4.4, 4.3 kilometers, something like that. Just go from there, going up. And you touch the line. And you can see. Yeah, somewhere like, okay, over there. Somewhere around that. So it should be about 4.2, 4.3 kilometer, I think.
Oh, can you hear me now?
I do.
Oh, sorry. My mic was muted.
Don't worry, you don't talk much anyway. Okay. Now, create a table of values for data on the graph. It seems like the topic's getting longer and longer.
Can I take a little break for a few
Sure,
minutes?
let's take a little break. Alright, let's get back. A table of value for the data on the graph. Seems to follow a linear relationship. Okay, you have to find that equation.
0.2 minute 0.2 kilometer per minute. So it's like somewhere here. So 0.2. It's 1 minute, so 0.2. So
Initial value is 0. So basically, b equal to 0 now. So basically, rate is 1 over 5 kilometer per minute, which is
So it's
also
like
0.2. I mean, 1 divided by 5 is 0.2, of course. So it's gonna be like, distance equal to 0.2 times time. I mean, it's gonna be like that. Because initial value is 0, so you don't plus anything else.
distance equals 0.2. So it's like 0.2. 0.2 t is uh, so distance is equal to 0.2 t. And that's it to like 4.1.
Alright, that's all for 4.1. Let's move on to something else. I'm sure there are more, like 4.2 or something, maybe?
Yeah, sure.
Okay, let's do it.
Yeah,
And share your screen and then microphone too. Okay.
it's right here. There. In this course, you have constructed a graph from an equation by first creating a table of value. Now you learn how to go directly from an equation to a graph by using two facts you learned in an earlier learning activity. The initial value of a linear relation is starting point of the graph. It is the point on the dependent vertical axis that the graph starts from, also known as the y.
Y-intercept.
The rate of change of a linear relation is the amount of the dependent
Or we call
vertical
vertical
axis
axis.
variable change when the independent
Horizontal axis.
horizontal axis variable change by 1 unit.
Mhm.
It is important
To know that the
to note
initial
that the
value and
initial
rate of
value,
change. Mhm.
uh, yeah, and rate of change of the linear relation appear directly in the equation. The initial values appear as the constant term without a variable, and the rate of change is coefficient of the variable. This means that you can construct the graph just by looking at the equation, describing relation with words. Now it's time to apply what you have learned about linear relation and make connection between the different way they can be represented. Consider the following scenario about a mother who walked to her car to receive grocery. You can express this scenario as an equation if you know the initial value and rate of change. Alternately, you can determine the initial value and the rate of change if given an equation.
Mhm.
This is not mother from her front door. So 1 second is 2 meter, 2 second is 4 meter, and with a second is 10 meter. If you calculate the first difference in the table, you you see that every first difference is 2 since the first difference are constant. The relation is linear. Since the relation is linear, it has a constant rate of change. What is the rate of change? Well, that the rate of change is the same as the first difference. On the
On the
table,
table.
since the first difference is 2, the rate of change the rate of
2 meter per
change
second.
is, yes, sorry. The rate of change is 2 meter per second. This is often written as 2 meter slash second
Second, using the short form.
per meters and second. Unit for rate of change are always the unit of dependent variable divided by the unit of the independent variable.
Mhm.
In this case, what would be the meters slash second? In English, the divide by sign is often replaced by
Like
per.
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 Remember that when you see the per in a sentence, it's mean divided by, like, for example, per cent, which mean divided by cent mean 100. So percent mean
Yeah.
divide by 100. Mhm. So per annum divide by a year. Per week divide by a week. Per month divide by a month. Something like that.
Yeah. If someone said that the mother started at her front door and she walked at a rate of 2 meter per second, you can see that you could create this entire table. If she started at her front door, her initial value is 0 meter, right?
Mhm.
So you could enter 0 in the time column and 0 in the distance from the door, from the front door column.
Okay, and let's move down. Yes, so I start 0, distance from front door, 0. So she's right there at the front door.
And after the next section, you have to say 2 seconds. The distance would be 2 meters farther, which would mean she is now 4 meters from the door. Notice that you need to include 2 things in your verbal description so that you can create a table of value for the relation. In the
Wait.
example, you have to know where to start the table, 0 for the time, the independent variable, and 0 for the distance
From
from
the
the
door,
door.
which is dependent variable. Just remember that the y is always like dependent on the x. Or
Yeah.
distance here, it depends on the time, you know.
A verbal description for a linear relation is contained. The initial value of dependent variable, the value of the dependent variable when the independent variable has the value of 0, the rate of change for the relation. Bag contained cracker with a mass of 6 grams each, and the bag has a mass of 15 grams. Write an equation for relating the total mass m in gram to the number of cracker in the bag. The equation would be total mass equal mass bag plus 6 times number of cracker, or m equals 15 plus 6n. Following example will show you how to apply the step of just learning and creating a graph using an equation. Remember, this is one way to create a graph. This method works best when the rate of change and initial value
values are numbers that are easy to read.
and work with a graph. Otherwise, creating a table of value or using graphing software is the way to go. Swimming lesson. The equation giving cost of swimming at a fitness club is C equals 10n plus 100.
So you have
Where
to
C,
pay a flat fee of 100 first. And then the number of people, it's n. Every people is like $10, something like that. Flat fee is like 100. That you always have to pay like 100 and then plus something depending on how many people, you know.
where C is the cost in dollar of taking the lesson, and n is the number of swimming lessons
Swimming
taken.
lesson taken.
Step 1. Identify the initial value and rate of change, and put them in context. So, this would be
Identify the initial value and rate of change and put them into context. So what do you think? Initial value is of course 100. You always have to pay that much, right?
yeah.
And the rate of change is like $10 per person, isn't it?
Yeah, that's true.
So
the initial
no, not per person. $10 per lesson. I mean, that's quite cheap.
value is $100. Whoops, $100, and the rate of change is $10 per lesson.
Mm-hmm.
Oh my god.
Oh, stop again. Okay, let's go. Come back, come back, come back. Please.
I'm here, I'm here. Wait, hold on, hold on. It's
Mm-hmm.
going. It's coming back, it's coming back. Just share it quick.
Choose a scale for each axis and set up a graph. Your microphone.
Oh,
Okay.
sorry.
Oh wow, okay. I'm used to it already. Now the movies stream and cost $2 per movies.
So
So you have to pay a flat fee of 20, and then every movie is like $2 per movie. Nothing
yeah,
is free anymore, you know.
that's
Nothing in
so
this world
expensive.
is free. Nothing is free.
It's kind of harsh.
Of course, it's harsh. Life is harsh. It's not like fairy tale movie when everything is free. It's not.
Do you like pizza with that? Basically, extra large pizza, sauce and cheese at pizza
No, I
place.
like I like only like medium pizza. Well, because extra large pizza is basically just like dough, and you don't have much on there anyway. And then you would feel so bloated because you eat too much bread, dough.
I like
It's
bread.
just like normal. Okay, let's say normal size, and then maybe extra cheese, extra olives, extra fruits pieces, something like that. I'm a very health conscious person. Of course, because I'm a pharmacist, which makes sense. Used to be a
Yeah.
pharmacist.
A basic extra pizza, sauce and cheese that costs $10.99. Customer charge 0.99 for every pizza topping,
Every extra
so
topping.
just plus 0.99 for each topping, so it'd be like 11.98. $12.97, $13.96,
$14.95. You cannot have five
$14.95.
toppings, right? Because too much topping, it will fall out of the pizza. And you need something to stick them together. That is the cheese. They just have to pour the cheese on top, and then the cheese will immediately solidify, and then they just covered up like layers of topping. But when you eat it, oh my god, all the thing just the flavor just bursts in your mouth.
It just mix, so it doesn't.
Exactly.
You're full of hot air. So altitude, height, the hot air.
Oh my god. The
So when it's
sky,
released,
it looks so
it's
gloomy today. It looks really gloomy today now.
I think it's gonna rain soon.
Say again?
I think it's gonna rain soon.
Um, yes, I believe so too.
Just have to
Moon
hurry.
and Neptune. Oh yeah, it's gonna rain soon, I think. Probably it's gonna float tonight, I think. Maybe float. It's gonna float.
Try it. What would Sydney Crosby say? Right in
Crosby, is
the
it Crosby? I
description.
think it's Crosby.
Yeah,
Like rugby, Crosby.
Crosby.
Yeah, you know the sport name rugby, right?
Yeah, rugby.
Rugby, so Crosby.
Huh.
Sidney Crosby say
That's hockey.
hockey player from the N boards.
Symbol of hockey player from the N
Okay, so I
board.
think from here on it's just going to be the same thing. Graphing lines, and I think you just have to spend time solving them. Uh, it's time already. I should go now.
Right. Have a
Okay,
good
I'll see
weekend.
you on Monday, okay? What shall we do on Monday then?
Um,
On Monday. You plan?
I think I'll think about it.
Say again?
I can type you on Zello.
Sure, let me know, okay? I gotta go now. I'll see you then.
Yep. See you. Have a good day.
Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.